This module is all about tilt. Now, what is tilt? Well, it's an important factor that you're going to have to relay to your customers because we have to take this into consideration when building out these proposals. The tilt of the solar panel is also known as the pitch, and it will impact the amount of tilt towards the sun for the PV array. Most arrays are flush mounted, meaning that they're going to follow the same pitch as the roof itself, but they're raised a few inches above it. If the roof is flat or nearly flat, it may be desired to tilt the solar panels on the roof to achieve the optimal angle towards the sun. Now, why is there a bunch of different tilts on here? Well, we've got a couple different types of roof planes, but this would actually be very optimal for year-round production. Why? Well, when we're building out these systems and building out our proposals for our homeowners, we need to figure out the angle of inclination depending on where you are geographically in the world. That's right. The tilt is affected by your place in the world. Now, let's say, for instance, in December, 23 degrees is going to be a great tilt. And then in March, it's going to be 47. And in June, we're somewhere around, 70 degrees, right? Well, optimal year-round production would be around 43 degrees. Most roofs are going to be just fine by having it flush mounted. But if you could take a look at the porch that this was installed on, that's a flat surface. We need to try and capture the most sunlight all day long, all year round. So when a customer's asking, are my panels going to be tilted up? They're wanting to know if it's going to be tilted like this. Well, the answer is going to be no 9 times out of 10 unless the customer has a desire to do that. What we're looking to do is have them flush mounted. Typically, it's only going to be a couple of extra panels on a tilt that's not ideal to be able to achieve the optimal kilowatt hour production for that customer. So if they don't want them tilted, we can always add panels to compensate for the losses because of the tilt. So, like we said before, location. Does it affect the tilt? Absolutely, 100% it does. Geographic location is a major factor. Because the Earth rotates around the sun on a tilted axis, higher latitudes or areas furthest away from the equator will yield lower levels of production. So you can take a look at this map. The bright red and orange, those are going to have higher yields of sunlight. And then you go all the way down to the blue, and you see that mainly in places like Alaska. The rest of the country is green to red. Down in the southwest where I'm at, we have a lot of solar production. But there's still a lot of great production around the country. So we have to take this into consideration when building out this proposal. We might need to tilt it a little bit higher in certain locations and a little bit lower in other locations depending on where you are geographically. So, does the roof type matter? Again, absolutely it does. Depending on the part of the country, the builder, or even personal preference, there are different roof pitches that can and will directly affect the solar installation. This will directly impact the tilt of the panels. Conventional slope roofs are the most common with residential roofs. This means that the slope is pitched between 412 and 912 on most homes. Roofs that exceed 912 are called steep slope roofs, and we can't install on those. So, why is this important to understand? Well, when we're taking a look at this thing, so let's take a look at this 812. The roof type does directly impact the actual production of the panel and whether or not we can install it. So on an 812, we can't exactly take a chainsaw and lean back the roof that we're installing on, right? So it's just going to be a flush mounted system. But on a 612, it's close enough. Most new homes are between a 412 and a 612 pitch. So we won't be seeing crazy tilts like we saw in the animation prior, where we have to see a big build out. What we can do is make sure that the customer understands that if they have a flat roof or a nearly flat roof like a 212 pitch, that there will be a tilt in order to be able to maximize solar production. So how do we fix this production? Well, adjusting the tilt can help compensate for losses based on geographic location. By adjusting the angle of the panel, the amount of direct sunlight can be controlled. So for solar panels to get their best performance, a steep angle of 60 is best. All right? Now during spring, the best angle is going to be 45. And during the summer, when the sun is at its highest peak, a low tilt at 20 is going to be optimal. So because solar panels are mounted on the roof, it's important to determine the best angle for year-round production. And this is what our solar proposal designers do on the back end before you ever get a chance to show your homeowners. So let's take a look at the different types of mounting based off of the actual pitch of the roof. When you see them all put together like Legos, that's called a fixed mount system. That means that you have a sloped roof and it's going to follow the exact slope line of the roof and be mounted flush against the roof itself. Well, what about tilt for a flat roof system? Well, as promised, I'm going to discuss this with you guys. So this is a flat roof, and as you can see, there's a tilt on each one of these panels, but they're spaced apart. This is done to avoid shading concerns on the actual panel itself. So installing solar on a flat roof requires a different type of racking system, which can be more expensive. An offset of at least 3 feet in between each racking system is done in order to be able to adjust to the correct tilt. The largest benefit to flat roof solar is the system can be installed on virtually any azimuth, and we can tilt the panels to almost any angle that we need to. Solar panels will cast a shadow behind them because of their angle. So to avoid creating shade on the rest of the equipment, the correct distance is necessary between each panel. Too close together and the shadow will affect the production. Too far apart and you'll reduce the number of panels you can fit on the roof, affecting the system's size. So 3 feet is typical, but it can be less, can be more. Again, depending on geographic location, this could be a factor. This is what our proposal builders do on the back end that you guys don't have to worry about. We make sure that you guys know how this works so that you're confident when delivering the information to the customer. So this is called an open mount system. You can tell if it's an open mount system because you'll see a row of panels with a space in between and then another row of panels. Whenever you see this type, you know that you're pitching a flat roof system, not a fixed mounted system. So this would be an open mount. So here's an example of how this is going to cast a shadow. So take a look, just as the person is, they're standing too close and the shadow is going to be cast onto the panel. But if they're spaced properly apart, you're not going to have any shadows from the actual panel themselves. So we're getting the shadow angle, the height of the panel, the width of the panels, and these are all being determined on what's going to be the best distance in between each panel before they ever get installed. Now, the last type of tilt that you need to know about is called a reverse tilt. Reverse tilt refers to tilting the solar panel south on a north-facing roof. This may also be a concern for your customers. So if they ask, are my panels going to be sticking up off my roof? It could be either they're wanting to know if it's going to be a reverse tilt or because they have a pitched roof, if it's going to be a standard tilt. In most cases, the answer will be no, unless it's otherwise noted by the projects team.